So welcome everybody to this latest video 162 Maths, and in this video we'll be doing some GCSE Maths high revision on the topic of trigonometry with right angle trig, or what I like to call SOHCOHTOA trig. Now I'll include a copy of the questions that we go through in this video in the description below for you to download and have an attempt at, which I strongly recommend you do before watching through this video so you can see how your natural ability fares with the questions that we go through. Now, before we get started working through some questions relating to basic trigonometry or right angle trigonometry, or what I like to call SOHCOHTOA trigonometry, let's just go through some of the basics. So when you are given a right angle triangle and you're asked to find either an angle or a side, and where if you're asked to find a side, the triangle involves an angle, you're most likely going to be using trigonometry. If there is no angle involved and you've got a right angle triangle and you're working out lengths of sides, and it's always going to be Pythagoras. But whenever there's an internal angle given, or you either need to find that angle, it's going to involve trigonometry. Now with most steps, the first thing you do with regards to most steps of geometric and measure topics is to label the diagram. Now always start by labeling the angle that's given, and I'm not talking about the 90-degree angle, I'm talking about the other angle, as labeling that as theta. The hypotenuse is always the side that's opposite the right angle, so that's always going to be the hypotenuse, or h, whichever you prefer. The opposite is always the angle that's opposite the theta, and the adjacent is always the one that's left, or the side that contains the right angle and theta. Then once you've got this, it's just about remembering the rule. Now SOHCOHTOA basically means sine theta equals opposite over hypotenuse. Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. Now when finding the angle theta, you need to use the inverse of sine, or the inverse of cos, or the inverse of tan to find theta, and also know when to divide and when to multiply. Now that makes sense more in the working out, or multiply when finding sides or angles. Now one thing that maths teachers are trying to stay away from is the use of triangles. Now if you are familiar with science and knowing like force, mass, area, back in my day they used to encourage the use of triangles to help you remember certain formulas. Now the trig also refers to those triangles, although maths teachers were trying to shy away from those. But if I draw a triangle, and let's say you've decided that you're definitely going to use sine, then what you should find, if I write sine theta here, and this is the opposite, this is the adjacent, then depending on what it is I'm trying to find, that will allow me to know what to do in terms of multiplying what, dividing by what, should help me with this. Now also you can then do a triangle for cos, and hopefully you can see how I'm creating these triangles. And for tan, again, excuse the triangles I'm drawing, and that's going to be adjacent and the opposite. I don't know why I wrote ADG, J rather, I can write A. So again, if you're not sure about how to know when to divide, once you've substituted the numbers into these SOHCOHTOA formulas, use the triangles to help you decide which you've got to do, and hopefully that should make it a little bit easier. So let's go straight into working through some questions. Now a little reminder, if you're wanting access to these questions, all you need to do is just click on the link in the description below and you can have access to these questions. So for question 1, it says label the adjacent, opposite and hypotenuse sides of the triangle below. It doesn't say part A, we'll just assume that's just a random part. So let's do this. So again, this is going to be my theta. So the hypotenuse is always the side that is opposite the right angle. The opposite is always the side that's opposite theta, and the adjacent is the side that contains theta and 90 degrees. Then for 2a, it says which trigonometry ratio would you use to work out the missing side of this triangle. So here I've got, well, if I label everything, I've got theta, h, o and a. Now I haven't got any information on h, so I can get rid of that. So what I'm looking for is which trig ratio uses o and a. Now if I go back to my formulas, I should recognize that it's going to be tan. So tan theta equals o over a. So there I'm going to circle tangent, which is the elongated word representing tan. Then moving on to 2b, it says which trigonometry ratio would you use to work out the missing side of this triangle? Circle your answer. Well, here I've got h and this is my a. So which trig ratio uses a and h? Well, that's going to be cosine. Then moving on to question 3, it says what is the value of sine x in this triangle? Now this question might seem very simple, but it is worth 3 marks and it isn't as simple as one may seem. So first things first, let's have a look at what sine x equals. Well, sine x equals the opposite over hypotenuse. Now in this triangle, I've been given the opposite, I've been given the adjacent, but I don't know what the hypotenuse is. So what I need to do is I need to find the hypotenuse. Now to do that, because I don't know any angles, I'm going to have to use Pythagoras. So here I've got h squared equals 4 squared plus 5 squared. So h squared equals 16 plus 25. So h squared equals, and it's going to be 41. So therefore h is going to equal the square root of 41. So then substituting o equals 4, h equals root 41, sine x is therefore going to equal 4 over 41, and there is my final answer. Now this could easily appear on a non-calculator paper, because as you can see I've gone nowhere near a calculator. I've not worked out the answer to root 41, I've just left it in its exact value. And that's going to be our non-calc answer. And if it was on a calculator, I'll just simply type that into my calculator. So 4 divided by root 41 gives me an answer of 0.6246950476, or 0.62 to 2 decimal places. Moving on to question 4, it says work out the length of x. So again, labelling the triangle, this is theta, that's h, this is going to be o. I don't need to worry about a because I've got no information on that. So which trig ratio uses o and h? Well, it's going to be sine, so I've got sine x equals o over h. So if I substitute the numbers in, I get sine 40 equals x over 21. So then I want to make x a subject, so we need to take the 21 over by multiplying by 21. So then I get 21 times sine 40. Now personally speaking, I always like to have the number multiplied by the trig ratio at the very front, because what you don't want to do is if I get my calculator, and hopefully it loads, and I then type in sine 40 times 21, as you can see the bracket isn't closed, and what it will do is it actually do 40 times 21 first and then use the sine function, which is what I don't want. Now if I wrote it with the 21 at the front, even if I don't close the bracket, the calculator will still give me the right answer. So if I press equals, it gives me an answer of 13.5 to 1 decimal place. And let's try not write the answer with a highlighter. So it's 13.5 to 1 decimal place. Now as you can see, there is no indication in this question how they want me to write the answer. So I could, if I'm rounding the answer, always make sure that you're writing whatever you're rounding it up to. But if your rounding is rubbish or you're not that confident, then feel free to just copy whatever is on your calculator, because if you have rounded wrong, you will lose a mark for it. So again, just make sure that you are doing the right thing. Moving on to question 5, again, we've just got a normal triangle. So the first thing I want to do is label. So I've got theta, I've got o, and I've got a. So the trig ratio I'm going to use is tan. So tan theta equals o over a. Now, you don't always have to write down the formula. That's not going to get you a mark, but you will have to show evidence that you have used that formula. So if you've already got all your formulas locked down, memorized in your head, you don't need to worry about writing the rule. But one thing I would certainly do is write down where you've substituted numbers in. So I'm substituting y, I've got 18 over 24. So just by writing this is clear evidence that I've used the tan ratio and I've substituted the numbers incorrectly. So then all that's left for me to do now is do the inverse tan of 18 over 24, and that should equal y. So if I then use my calculator, I get an answer of 36.9, and that's to 1 decimal place. Moving on to question 6, it says work out the length of z. So again, labelling, I've got theta, I've got h, and I've got a. Now in this case, I'm going to use in cos, so I've got cos 32 equals 15 over z. Now again, at this stage you might be thinking, oh, I'll just do divide, take the 15 over, but actually we don't. If we go back to that triangle in which I've got cos theta and I've got the adjacent and the hypotenuse, so here if I just swap these with 15, and this is z and this is 15. Now if I want to work out z, that's going to equal 15 over cos 15, and this is what I type into my calculator. So if I then do 15 divided by cos 15 equals, and that gives me a cos 32 rather. Oh. And that's 15 and that's 32. Then what I end up with is an answer of 17.7 to 1 decimal place. Then moving on to question 7, it says work out the area of a trapezium. Well, the area of a trapezium is a plus b times h divided by 2, where a and b are your two parallel sides. Now in this particular question, I know what a is, I know what b is, but I don't know what h is. So if I take that triangle out, I've got this angle here, which is 58, and then the base of that triangle is going to be the difference between a and b, which is 4, and I need to work out what this is. Now h is the height, but also h in trigonometry means hypotenuse. So what I'm going to do is I'm just going to change that letter because I do not want to confuse myself, and I'm just going to call that x. So looking at this, I can see I'm going to use tan, so I've got tan 58 equals x over 4, so x equals 4 times tan 58, so x equals, and then just typing that into my calculator, 4 tan 58 equals 6.401338 blah blah blah. So now I know what h is, so I can cancel the x and just call that h. So then to work out the area, it's going to equal 12 plus 16 multiplied by 6.401, and whatever you've rounded that up to, divided by 2. So I've still got that answer saved on my calculator. So if I then type in, well, 12 plus 16, and let's just show you how I've done that. So let me just quickly store for tan 58. Press equals. So that's my answer. I'll just write down a few digits just for working out purposes on the question, and then entering the area, I press my fraction button. I've got 12 plus 16, which is 28, so it's going to be 28 times the answer, which is that 6.401 number, and then divided by 2, press equals, and it comes up with 89.6, so 89.6, and that's to 1 decimal place. Moving on to question 8, it says AB equals AC. Work out the size of angle BAC rather. So it's this angle that I'm wanting to work out. Now, to start off with, we know it's, if I divide that isosceles triangle into 2, then this length here is going to be 8, and this length here is 24, and I just call that x. And let's just colour half of that in. So BAC equals 2x, because it's going to have two lots of those. So then if I then take that triangle out, I end up with, oh, not this angle, so let me get rid of that. It's this angle here that I'm trying to find. Here is my right angle. This is 24 and this is 8. So then labeling this, what I get is this is my opposite, that's my hypotenuse, so I'm going to be using sine. So sine x equals, and it's going to be 8 over 24. So then inverse of sine of 8 over 24, which is a third, equals x. So x equals, and if I type that into my calculator, I get an answer of 19.471, and then if I multiply that by 2, it gives me the angle of BAC. So times 2 equals 38.9 degrees, and that's been rounded to 1 decimal place. Now moving on to question 9, it says A, B and C is a right angled triangle on ground level. DB is a vertical mast of height 12 meters. The angle of elevation from A to D is 42 and the angle of elevation from C to D is 35. And the question is asking us to work out the distance of AC. So first of all, let's highlight what it is we're actually wanting to work out. So here I can see this is the line that I'm wanting. So let's just start by calling that X. Now, in order to find that length, I can see I've got a right angle triangle. And if I draw that triangle out, then this is X, that's A, that's C, and that's B. And this is a right angle triangle. Now, in order to work out X, I either need to know one of the angles, internal angles, and one of the sides, or know what the other two sides are. Now, unfortunately, I don't know any of those, so what I need to do is go about finding them. So if I start by taking this right angle triangle, and I just draw that out again, in which I've got A, D, and B, I can see that DB is 12, and this angle here is 42, and this is AB is the angle that I need to find, so I'm just going to call that X. So using this triangle, I'm going to use tan. So I've got tan 42 equals 12 over x. Then using the little triangle, I get x equals 12 divided by tan 42. And if I type that into my calculator, I get an answer of 13.327. I think 3 decimal places should be fine, but I'm going to leave my answer as that. Then moving on to the next side, if I draw this triangle here, which I'm going to highlight in green, and I draw that triangle out again, I can see that, and just label the sides. So this is D, that's B, and that's C, and this angle here is 35, and this length here is 12. And I start by calling BC X. Then again, I'm using tan again, so I've got tan 35 equals 12 over x. So again, x is going to equal 12 divided by tan 35. So x is going to equal 12 divided by tan 35, which is 17.138. So then what I then need to do is then substitute these two numbers. So this is the length BC and this is the length AB. So substituting this in, AB is 13.327 and BC is 17.138. So then using Pythagoras, what I get is x squared equals 13.327, or whatever you've rounded that number to, squared, plus 17.138, and whatever you've rounded that number to, squared. So typing that straight into my calculator, I get, now again, depending on rounding, you may have a different answer to what I'm going to get. I'm going to use 3 decimal places, those numbers, in which I get an answer of 471.319973. So therefore x equals the square root of that answer, which is 21.7, and that's meters to 1 decimal place. So as long as your answer is close to that and you've showed full working out, then that should be absolutely fine. So then moving on to our last question, it says ABC is a right angled triangle. Use trigonometry and Pythagoras' theorem to show that sine squared A plus cos squared A equals 1. Note that sine squared A is a mathematical way of writing sine A all squared. So first things first, let's start by labelling the angle of A, and this is my angle A. Now the fact that the sides are labelled ABC is absolutely fine if you're using Pythagoras, but not fine when we're using trigonometry, because A is usually used to represent the adjacent, so do be mindful of that. So first things first, let's work with angle A. Now I know that sine, because I want something involving sine and cos, well, to use sine A, I need to use the opposite, which is A, and the hypotenuse, which is C. So that's going to be equal to A over C. And the reason for that is because I'm using these letters here. Then to work out cos of A, well, cos of A, to use cos, I need to know the adjacent and the hypotenuse. Now here the adjacent is B and the hypotenuse is C. So that's what I've got so far. Now using Pythagoras, now if I just rearrange these formulas, so here I get A equals, and it's going to be C sine, let me just make sure that S looks like an S. So it's going to be A sine A, and this is going to be B equals C cos A. Now all I've done is just rearranged. So from here to here, all I've done is rearranged. Now what I'm then going to do is I then use Pythagoras. So rather than writing, I know that A squared plus B squared equals C squared. So using A squared plus B squared equals C squared. Now instead of using A, I'm going to use this instead. So here I've got C sine A squared plus B, and so I'm going to use this. So it's going to be C cos A. Let me just write that a little bit neater because I don't want it to be confusing. C cos A all squared, and that equals C squared. Now expanding the brackets out, I need to square. Like if you had 2x cubed, then that would be 2 cubed times x cubed. Now using this notation, I'm going to do C squared, so that's become C squared, and then sine A squared, which again using this can be written as sine squared A. Then I do the same with the next one, so C squared is going to be C squared, and cos A squared is cos squared A, and that equals C squared. Then what I can then do is factorize this. So if I factorize that, I can take C squared out, in which I've got C squared, and then here I've got sine squared A plus cos squared A, and that equals C squared. I then take the C over to the other side by dividing by C squared. So what I end up with is sine squared A plus cos squared A equals C squared over C squared. And what's C squared over C squared? Well, it's 1, which is what they wanted me to prove.